So then I can actually export this out as a STL mesh. It's not watertight in this case, because at the back of it, it's just a skin. So there's nothing there. There's no thickness. It's just a surface skin. If we went all the way around, we could get that basically done as a solid and hold fill the whole thing. So then we can export this out and do base. And I can choose a range of file formats out of this particular package to export it as. So in this case, I'll just do it as apply, and then we've got other packages which we can open that up and do further things too. So that is a mesh at the moment. So what that means is if I zoom in, it is literally just a wireframe. It's not a mathematical surface. It is a range basically of dots joined up to make a mesh, which would go to 3D printing or for machining. If you want to do something with it in Creo or SolidWorks or something else, we need to actually convert that over to a different file format. And that's what this program here does. So if I took it into this program here, so this is one of the automatic conversion programs that takes mesh data and can convert it over to a NURBS or engineering file format. So there's things like this where we can actually, for instance, I'll just take off everything below the neck. So essentially this is like a 3D photoshopping package. Take off the ears. So I'm just giving you a bit of custom surgery. Okay, I can fill in all the holes essentially. So on this one I can fill in all but the largest, and it fills in all the holes automatically. So I've got little holes up in the nose. We can clean the file a bit. I can smooth it. I can remove bits which are noisy. And then there's a function here which will go to what we call exact surfaces. So do one thing, which is repair the file. So this software package is actually often used to repair files for 3D printing as well. So that's done. So I've just fixed the file up, and suddenly I've got 161,000 polygons, which is fine. I'm going to come to here, and basically what I'm going to do is press one button, and it's going to put a mathematical surface automatically over the face. So that will just take a few seconds. Almost done. It's best fitting. Each picture has a shape, and each picture is very close together, so it's just doing what we call a best fit, least squares reduction. It's a maths technique. Sorry? Very similar, but the shape is accurate. So what is happening is that your face has changes, or any picture in that scan has changes in 3 dimensions. So it's like if you're all CAD operators here, aren't you? You use parametric CAD programs. So when you put an assembly together, you've got to constrain 2 parts together in 3D. You've got to give it a position and lock it in with another component. If you don't, it's unconstrained. Same with 3D scanning here. We've got 2 pictures. They're overlapped. They're constrained in 3D fully, so they do a best fit and have basically get rid of the error between them.
In the actual surface.
Yeah.
And the
Yeah. So the surface itself is actually. Yeah, I'll just bring it back up here. So let me just open up frame 1. So that's a frame there. If I bring it back to your surface, and then this is the frame before it. So what happens is the blue frame's there and the pink frame are fitted together. So you can see all that colour where it's mottled. That means they're cut right through each other, which means that they've been fitted accurately. If there's one colour that you saw, like purple or the blue, that means one's sitting above the other one. Okay, so that's how the technology works, and that's doing it in real time. Right, and this is now a mathematical NURBS surface. So if you look at the structure of this now, this is now a surface boundaries. So it's a high density patch structure. We can reduce or increase the patch density at our leisure, essentially. We can import factors into that. But if I export that now, that is now a true work surface, and that will go into SolidWorks. If I could have thickened it in here and made it thick, and that would have gone into SolidWorks as a solid then. And you could then actually manipulate it and do stuff with it. And there are other options now where you can actually create parametric surfaces. So if it was an engineering part, you'd actually have history which would go into SolidWorks or Creo now from a reverse engineering package and get it back to design intent.